Hello friends, good morning all of you. So welcome to my channel and please subscribe to my channel for new videos, and we are going to explore one by one. So far we have discussed about the cerebral cortex, then the functional areas we have seen, and the basal ganglia, thalamus, and also we have discussed about the amygdala. In the limbic system we have discussed about so many structures like amygdala we have discussed, and also the hippocampal formation, and what are the other structures we can identify? Structure of the hippocampus. So what are the cells we can identify? These are all the structures we have seen in our previous classes. So for that, if you want any clarification, you just go through the books once again and try to study once again and make notes, all these things. So why don't we just we'll go through this memory process, hippocampal formation and the memory process. So what about this hippocampal formation and memory process is? So neurons of hippocampal formation and their intrinsic and extrinsic connections for short term memory. So first we'll discuss about the is coming to the short term memory. Short term memory, it is an unidirectional progression of synaptic activation facilitates the short term memory process. It is also called as episodic memory. Okay, episodic memory. So how it goes on, let us see that. So first, the information from entorhinal cortex, it's also called as parahippocampal gyrus. You can identify in this diagram. This is nothing but the parahippocampal gyrus. So from the entorhinal cortex or the parahippocampal gyrus, the impulses they reaches to the dentate gyrus. They reaches to the dentate gyrus. Then after that, from the dentate gyrus, it is reaching to the CA3, means carno ammonis 3. Let me show you that. Yeah, here you can identify the dentate gyrus. So from the dentate gyrus, the impulses are reaching to the carno ammonis 3. Okay, CA3. So in the carno ammonis, as we have discussed earlier, there are three areas over there: CA3, CA2, and CA1. CA3 is near to the dentate gyrus, and CA1, which is it is continuation of the subiculum. So from the dentate gyrus, the impulses they reaches to the CA3. Okay, so this pathway it is called as perforant pathway. Perforant pathway. So from CA3 to CA1, from CA3 to CA1, this pathway, as it obviously it is passing through the CA2, such pathway is called as Schaeffer's collaterals. Yeah, can you find this? Yeah, try to see, observe carefully. So from dentate gyrus to the CA3 area, then CA3 to CA1 through the CA2, this pathway is called as Schaeffer's collaterals. Schaeffer's collaterals. Then from the CA1, so it is reaching to the neurons of subiculum. It is reaching to the neurons of subiculum. Then after that, from the subiculum again, it enters into the parahippocampal gyrus. You can see clearly over here. So this is how the short-term memory or episodic memory process will take place. Okay, so this is about the short-term memory, and let us see the inputs. So there is no feedback loop between CA3 and CA1, CA3 and dentate gyrus, and between CA1 and CA3. There is no loop is present between dentate gyrus and CA3 and CA3 and CA1. Okay, so that is about the episodic memory. Let us see the input of it. Let us see the input. So how the input is reaching to the parahippocampal gyrus, that we will see now. So the input, it is entorhinal cortex. It is receiving information from sensory association areas. So far in the white matter of cerebral cortex or white matter of cerebrum, we have discussed about different types of fibers. In the white matter, we have seen the association fibers, then the projection fibers, commissural fibers we have discussed. So the association fibers are the fibers which are connecting the gyri of the same cerebral hemisphere. Gyri of same cerebral hemisphere. So gyri, as already have seen that. So gyri of same cerebral hemisphere, gyri, they are connected by the association fibers. So we have discussed short association fibers and long association fibers. So the short association fibers, they connect the adjacent gyri, whereas the long association fibers, they connect the gyri which are far with each other. Okay, that is about the association fibers. So through these association fibers, the entorhinal cortex or parahippocampal gyrus is receiving inputs. Okay, here you can identify how the association fibers are present. Okay, so here you can see the long association fibers, how they are running from anterior to posterior, from frontal lobe to the occipital lobe, and from frontal lobe to temporal lobe, how they are running. Already I have seen in the white matter of cerebrum. In the same way, the association fibers, they are bringing the receiving information from sensory association areas from frontal lobe, parietal lobe, and temporal lobe. Remember, frontal lobe, parietal lobe, and the temporal lobe. Okay, then what happens to the output? Output. So main output of hippocampal formation, including the commercial fibers, is derived from the axons of pyramidal cells. Axons of pyramidal cells, pyramidal cells of CA3 means the Carnot-Ammonis 3. So in the previous class we have discussed about the three layers, molecular layer, then pyramidal layer, and the polymorphous layer. So three layers already have seen that. So in the pyramidal layer, we can identify the pyramidal neurons. Pyramidal neurons. So from the pyramidal neurons, which are present in the CA3, uh, and from the subiculum, from CA3 and from subiculum, the neurons or cell bodies are present over there, and then they are going to the axons of the hippocampus, they forms the alveus. Let me show you this. Here you can identify from CA3 and from subiculum, the cell bodies are present over here. See in the CA3 and here in the subiculum, and then the axons which are forming the alveus. So they forms the alveus. Then at the one corner, that alveus means the white matter of this CA3 and the subiculum, it is going to converge and forms the fimbria, and then it is forming the fornix. The efferent fibers of the hippocampal formation, they are present in the fornix. Okay, they are forming the fornix. Then fibers of precommercial fornix. Here, yes, coming to the fibers of precommercial fornix. So under the output after forming the alveus, then converging part fimbriae and the fornix, the fibers which are extending anteriorly, and they are going to divide into two parts by anterior commissure. The fibers which are running anterior to the anterior commissure, they are called as precommissural fibers. The fibers which are running posterior to the anterior commissure, they are called as postcommissural fibers. The fibers which are running anterior to the anterior commissure, they are called as precommissural fibers. They makes connection. They are connected to the septal nuclei, lateral septal nucleus, and are derived from the CA3, means Carnot-Ammonis 3. Okay, so the lateral septal nuclei which is present in front of the lamina terminalis, between anterior commissure and the optic chiasma. So here already in the fornix class we have discussed, as they are going to connect with the paraterminal gyrus. At the same location, almost same location, there we can identify the lateral septal nucleus also. So the CA3 is connected to the lateral septal nucleus. Okay, lateral septal nucleus in front of the lamina terminalis. Then the postcommissural fibers. Try to see over here. So here I'm just showing you the post-commissural fibers. The post-commissural fibers which are running posterior to the anterior commissure, and they are going to connect with the mammillary bodies. Okay, mammillary bodies. And here you can see the pre-commissural fibers and the post-commissural fibers. Then after that, one postulated mechanism in the rapid formation of new memories is long-term potential. So which increases the synaptic efficiency that follows a few seconds of high frequency activity of presynaptic terminal. So this involves the Schaffer's collateral. Schaffer collateral means CA3 to CA1 through the CA2. That pathway is called as Schaffer's collaterals. Okay, so here once again I'm just showing you how these fibers are extending from the posterior after forming the alveolus, then fimbriae. The efferent fibers are extending anteriorly, and then they're going to divide into the two columns. Then some fibers are running anterior, some fibers are running posterior. Here I'm showing you the posterior fibers which are connecting with the mammillary bodies. The memory, we have discussed about the shorter memory, how the process goes on, and now we are going to see the long-term memory. So it is also called as potentiation. So the long-term potentiation, it is one postulated mechanism in the rapid formation of new memories. Okay, one postulated mechanism in the rapid formation of new memories. It is called as long-term potential. So it increases, which increases the synaptic efficiency that follows a few seconds of high frequency activity of presynaptic terminal. So this involves the Schaffer's collaterals between CA3 and CA1, that is Schaffer's collaterals, and the mossy fibers of the hippocampus. The effect lasts for several days and leads to increased activity of the affected postsynaptic neurons. First, listen. I will explain you about this long-term potentiation. Okay, long-term potentiation connected to the synapses of pyramidal cells of cornu ammonis and the granule cells of the dentate gyrus will continue to transmit impulses frequently, even though the original external stimulus has ceased. So the long-term potential is triggered by the accumulation of calcium ions in the postsynaptic neurons following high frequency activity. So to remember this one, to uh, explore this long-term potentiation, try to assume that when you're going to face any examination, suppose when you're going to face the final examination, and then you came to know that one particular question you are going to get in the examination. Okay, so that particular question, suppose hippocampal formation question only, you are going to face in the final examination. So if that question has been revealed to you, how you will study? You will study from the beginning to the end. So you will read it, and you will remember it. If the examination is going to happen the next day, or after 2 days, after 5 days, or after 10 days, but you will remember the question, you will remember the answer properly if you have studied about it. So that is called as long-term potentiation. So we are not giving any stimulus again and again, but the stimulus has not been given again and again. But if one time stimulus has been given, you will remember the thing. So that is called as long-term potentiation. Okay, so that is called as, what happens in the long-term potentiation is it increases synaptic efficiency that follows a few seconds of high frequency activity of presynaptic terminal. High frequency activity means, so you are going to see the question You are going to face the important question that is in the examination, final examination. That is like a high frequency, okay, high frequency activity. Okay, so it is reaching to the first presynaptic, then it is reaching to the postsynaptic. Okay, so this pathway is called as Schaeffer's collaterals and the mossy fibers. Understood? So that is about the long-term potentiation. The next one is hippocampus contains place cells that encode spatial memory in front of where I have been, where I have been. So recalling the places and of the routes followed to reach the places requires hippocampal activation. Okay, so the place cells which are present in the hippocampus, they are responsible for spatial memory. Spatial memory. Suppose when you're traveling to a particular place, when you're traveling to a unknown place, so the first time you feel very difficulty to approach to reach the particular place, but when you go to the second time, when you go to the third time, you will easily remember the roots of it. Okay, so the neurons are well developed, so the hippocampal neurons are very well developed in the elephant, so very well developed in the elephants. The place cells are very well developed in the animals, especially in the elephants. Why? Because if the elephant uh, finds some water over there, it will remember the place where the water it has found. It can remember after, even after 2 or 3 months also, it can come to the same place, though it is far away from its home place, far away from its home. Means, assume it might be 200, 300 kilometers, but it can remember the place and it can reach the place for that particular water. Why? Because the place cells of the hippocampus are very well developed in the case of elephants. Okay, then the fourth one is large pyramidal cells in the area number CA1. Large pyramidal cells which are present in the CA1 are exceptionally sensitive to oxygen lack, sensitive to oxygen lack, and die after only a few minutes without a supply of fresh arterial blood. So the cells, the large pyramidal cells which are present in the CA1, they will die immediately if it lacks the fresh arterial blood. Okay, the area of CA1 is known as Somers sector. Somers sector. Okay, so that is about the Somers sector. Then cerebral anoxia from any cause may lead to loss of memory of the events of the preceding few hours. So the many patients resuscitated after cardiac arrest of more than a few minutes and left with defective memory for this reason only. Okay, so because the neurons, they will die if that they does not receives the fresh arterial blood. So that is the fourth step. Then the fifth step of memory is the consolidation of recent memories. Consolidation of recent memories. Yeah, here you can see that. So the consolidation of recent memories may occur during sleep. May occur during sleep when the serotoninergic raphe neurons of the brain stem are active and project to the hippocampal formation. So in the deep sleep, so here you can see some graphs. In the deep sleep, the EEG means electroencephalogram, synchronized rhythms, whereas the hippocampal EEG, as recorded with the needle electrode, is desynchronized. In the waking state, the neocortical record is desynchronized, and the hippocampus generates a regular rhythm. So that is about the EEG in the deep sleep, EEG in the waking state. So once again, we'll discuss on this particular EEG in a separate class. Okay, so till now, you just remember the main things: the memory, short-term memory, and long-term potentiation memory. Okay, long-term potentiation memory. So for to remember anything, so what are necessary? The pyramidal neurons, which are very important in the CA1, and also the calcium ions, are important, and also the fresh arterial blood is important. So that's why you must take a proper diet and you must take a proper sleep. Okay, so thank you, dear students. See you soon with a new topic.